Hi AB Calculus class and BC if you're joining in. This is 2014 number 5. This is AB 2014 number 5 and the topic, this is a table question. From your packet, this is May 8th. Folks, this is what's going to be on your AP exam. You just can't do anything better than this. If the table gives you some information and they just say, hey, go use the information, this is going to be on your exam. I know it is. You'll notice when I filled this out, instead of writing the word positive and negative, I just put pluses and minuses. It's the same table. And instead of saying from -2 to -1, the way they wrote it here, -2 is less than or equal to x is less than or equal to -1, I just wrote it like this. And all the same numbers, f prime, g prime. Okay, so part A says find the relative minimum of f on the interval from -2 to 3. Justify your answers. So, how do you find out when something has a minimum, a maximum, or increasing or decreasing? F prime. A sign analysis chart of f prime x will tell you when f is increasing, decreasing, maxes, or mins. So let's look at f prime x. So for f prime x, we're going to make a sign chart. I'm going to label it. You've got to label your sign charts or you're not going to get points on the AP exam. Some of them. It's going from -2 to 3. And what goes on a sign chart is where things are equal to 0. So where is f prime x equal to 0? It's equal to 0 at -1 and at 1. So on this sign chart, we're going to put a -1 and a 1. And now let's look at the values. F prime x was negative, and then positive. So it was negative, and then positive. So let's think about what this means. If f prime x was negative and then decreasing, still decreasing, and then f of x was increasing. So decreasing, still decreasing. Nope, not a min or max, but over here, it was decreasing and then increasing. And this is a relative minimum. So you would say f of x has a relative minimum at x equals 1 because f prime x went from negative to positive values. So f prime x changed from negative to positive values. And that's it. That's part A. Oops, forgot to put. Sorry, that whole time that was part A. That's how you do part A. Okay, let's go to part B. It looks like part B is going to be the mean value theorem. So if you want to stop the video and try the mean value theorem, see how that might apply, it would be a good thing. Alright, so how did I know it was going to be the mean value theorem? Well, they want you to basically prove something about the second derivative, prove it would equal 0. Prove it equals 0 on the interval -1 to 1. And that C kind of helps me understand. So let's look at the mean value theorem. The mean value theorem says f prime C equals f of B minus f of A over B minus A. If you just watched the previous video, the mean value theorem basically states that if you have some sort of closed interval, if you can find the slope through the endpoints, find the slope through the endpoints, that's the old school slope through 2 points, the mean value theorem, if the function is differentiable and continuous, guarantees that f prime C, the slope of the tangent line, will equal the slope through the endpoints. So the mean value theorem guarantees at some point C, the slope of the tangent line will be the same slope as the slope through the endpoints. So how is that going to work here? We're trying to prove something about the second derivative. So we're going to state that if I want to prove something about the second derivative, I need to know the slopes through the first derivative. And that's what we're going to use. And they really help us out by telling us which ordered pairs we're going to use. So, if we're looking in the graph of f prime, what is f prime -1? F prime -1 is 0, and f prime 1 is also 0. So we would first start, because we're going to use the MVT, we have to say that the function is differentiable, and you can read it. It tells you that f is twice differentiable, so that means f prime is differentiable. So f prime is differentiable. Therefore, by the MVT, f double prime c should equal, now we're jumping into the formula, f double prime c should equal, now we're going to subtract the y's on top, the x's on the bottom. So these are the y's for f prime x, and then these are the x's. And you'll notice you get 0 over 2, so f double prime c must equal 0. And that's the end to that question. That's part B. Now let's go look at part C. If you really like math, you're going to get the part C and D and be like, yeah, this is good stuff. C is great, D is even better. But let's go ahead and look at what we're going to do for part C. Here we have h of x equals ln of f of x. And they want to know, the question is, what is h prime 3? But you can't find h prime 3 until you first find h prime x. So to find h prime x, we need to take the derivative, which means we need to remember what is the derivative of ln of u. So we have to have the formula memorized that the derivative of ln of u has u on the bottom and its chain du on the top. The derivative of ln of u is du over u, or u on the bottom, du on the top. So this is an ln of u, that's the u. So the derivative of ln of u has u on the bottom, f of x on the bottom, and its derivative on the top. Well, the derivative of f of x is f prime x. And now that we have the derivative, we're going to plug in the 3. So we get f prime 3 over f of 3, and we simply look the numbers up on the chart. What is f prime 3? So f prime 3 is a half over f of 3, which is 7. And you're done. That's h prime 3. There is no reason to try to simplify it. Yes, it's 1 over 14, but nobody really cares. Okay, so that's part C. And now let's go to the insanely beautiful question, part D. All right. So for part D, that's not a good start. Let me erase that. Okay, there we go. All right. We have no clue what to do here, but we do. We're going to follow the rules. Just as an example, let's look over here, because this is what's going to happen in this question. If I told you that we had f prime x dx from, let's say, 5 to 6, what would we do? What we would do is called following the rules. The first thing we would do is we would take the antiderivative. We would say the antiderivative of f prime x is f of x. And then we plug in the top and the bottom and subtract. So I'd plug in the top, f of 6, minus, and I'll plug in the bottom, f of 5. And then I would look those numbers up on the chart. Now I made this up so they don't exist here, but we're going to do something similar. Except instead of an x, we're going to have an f prime u du. And then we'll say the antiderivative of f prime u is fu. And we'll go on the question from there. So the idea is we know what the antiderivative of f prime x is, it's f of x, and we know what the antiderivative of f prime u is, which is fu. So, if you haven't done so, try stopping the video and doing u substitution. Just see how far you get. Use my hints from before. And if not, here we go. It's u substitution, and we're going to start by making the u g of x. And if the u is g of x, the du, the derivative of g of x, is g prime x dx. And look at that. That's what they gave us. If this is the u, this is the du. And it's beautiful. If you love math, you're going to love the question. If math scares you, you're a little scared. Now I'm leaving these numbers here, although technically they don't belong to the u's. So, when this is the u, this right here is the du. And now we'll take the antiderivative. Well, what's the antiderivative of f prime u? It's simply fu. However, we know what u is. U is g of x. So instead of fu, we're going to call it f of g of x. We're going to replace the u with g of x. And now we can plug in the top and the bottom and subtract. So we're going to plug in a 3. So we get f of g of 3 minus, and then we're going to plug in the bottom, f of g of negative 2. Alright, so let's go ahead and look stuff up. We need to know what is g of 3. We need to know what is g of negative 2. We're going to use the charts to find these two values. So g of 3 is 1. And then g of negative 2 is negative 1. And then we're going to look those up. So we're going to look up what is f of 1 and what is f of negative 1. So we look up what is f of 1. F of 1 is 2 minus, and now what is f of negative 1? F of negative 1 is 8. So our final answer is 2 minus 8, which is negative 6. Making sure it's correct. It is correct. It's a beautiful question. I hope you enjoyed it. Bye.